Welcome to the Triangle Apache Spark Meetup, or TASM. We try to meet every other month. I've not been that regular, but if you want to talk about anything Spark, please contact me and you can, of course, present here. I am your host, Jean-Georges, or JG Perrin, and you can follow me on Twitter at JG Perrin. Today, I'm really excited to have my good friend here, Dhiraj Peechara. We met a few years back, actually at a Spark meetup, and I love his passion for data quality. It's remarkable, and his commitment to data quality is also really laudable. So today he's going to talk to us about what he's doing in this regard at DataQ. And Dhiraj, the floor is yours.
Thank you, Jean, for giving me this opportunity to present today. I would love to share data observability and how we can improve data accuracy, which is the bottom line, and bring in automation for that. So, as I said, the main agenda today is to talk about data observability. I think the best way to describe data observability is it is like a camera or smart camera for your data. The reason I said smart camera is you not only go back in time to see how your data is, but you can also detect when something happens. Like in a school, when there's a fight happening, the camera can we can not only go back, but camera can alert that something is going on. That way, the authorities can take action. So just like that, so data observability is able to not only detect or go back in time to see your data snapshots and how they are doing, but it will alert you the moment bad data comes in. So that's the best way to define data observability in my opinion. So why data observability? Why even bother about data observability, right? So according to, you can see some of these industry stats and the amount of loss that happens because of bad data. In my personal experience, I have faced a couple of issues where one time in one of the organizations, we used to sell data weekly basis, and that week we sold bad data. And the result of that was we had to redo data recall, and that's expensive. And in another instance, one of the VPs of a company mentioned that the only time they realize the data is bad is when they look at the dashboards, right? And I can keep going on, but I'm sure you're all, if you're familiar in this space, you know the problems with data quality. So today what we are going to do is we will go through a simple use case, which it's very, we all used to see, and then see what are some of the problems that happens and how we can solve it, right? So in this example, we have a OLTP database, Oracle, Postgres, so on, right? And from that, every hour we are loading that into Snowflake, which is our data warehouse. And we have multiple of these transactional systems. And every hour we are moving that into Snowflake. And in Snowflake, we do the dashboards, aggregates, ETLs, and so on. Now, if any of these data sources, if the bad data comes into our transactional system, it's best to catch it right at the source, right? So now if, let's say we are the data engineers and this is one of the very basic process, when something goes wrong in this process, we ask some basic questions to troubleshoot. And I'm sure if we are in the data space, these are the questions that you get asked or you ask to troubleshoot by yourself as well. So the things are like, is the data loaded completely, totally, partially? Or what is the volume of data loaded? Is the data accurate? Now that's a complex question. When you say data accurate, it can have multiple attributes to that. Now, is all the data within the range Are there any anomalies? Are there any null counts? Or did the schema change? Column name, any column dropped? Ability to monitor this continuously on large amounts of data, that gives, it's like truly a camera watching your data. You can just go back in time, or it alerts you whenever something is wrong, right? Now, right. So here we have set data quality monitoring for both source and on the target. Now, after answering all these questions, we still see that there are some discrepancies. And then we would like to go and see how do you validate source with the target. Right? So again, for this demonstration purpose, we will take two simple tables, a sales table and a customer table. And these tables are every hour pushed into Snowflake. And of course, Snowflake has the whole historical data from all the regions. So to set up this, it takes approximately 2 minutes. And start monitoring this data. So at this point, let's go jump into the demo itself. Right. So this is the interface. Once we log in, this is where we land. And it is showing us the executions or the past executions. Now, first thing that we are going to do is we are going to set up a data source, right? And it is listing me all the data sources. So in my case, the OLTP database where the transactional data is Postgres. So I'm going to put raw data, OLTP, and define my connection. Okay. Validate the connection. The connection looks good. And I'm going to create the data source. Right. I'll skip the Snowflake part for now, but the same thing, we go create the Snowflake connection as well. Now, once I have established the connections, I can create a flow and use those use those connections in the flow. So here I'm creating a new flow in order to start monitoring the data. On the left side, we have various components. We drag and drop these components to create a flow. I drag the input component. That's the first thing that is needed to create or start data monitoring. I named raw data OLTP. I selected that. And in the public schema, I have two tables. Sales table and customer table. I have selected these two tables, right? Then I'm going to pull in data quality here. Right. So at this point, let's say you have this system going on, right? And you know that your data in your transactional database at this point initially is good. You have already validated that. So what we are doing here is it is listing us all the columns and all the rules that we can provide, or we can click on auto suggest. At this point, what happens is it analyzes the data and builds all these rules. So it is like training data, and if your input data has issues, then the rules that are generated are also bad, right? Just like you build a model. So here we expect that the initial data, even if it is a subset, is good representation of the data. So I'm going to click on auto suggest. At this point, it's analyzing the data and then building the rules for us. That should take about a minute. And once these rules are generated, we can add as a domain expert various additional rules. Like, for example, we have a complex business rules which says that if an ID column starts with K, then the value, the sales transaction value should be greater than 100 and less than 120, and so on, right? So those are the rules that we will be adding soon here. And as you can see here, all these rules are populated for us. You can have how many other tables, and all these rules are populated for us. We can go tune them. So in our case right now, what we'll be doing is adding some additional rules on top of these rules. Right. So that's one rule which is simple condition. So I'll go here. For the ID column, I applied this rule. Now similarly, that's sales table. And for the ID column, I applied that rule. Similarly, for the email, I need to apply the email rule, which I have predefined earlier. And I can go pull in email validation. Right? Now that email validation is applied to the email column, and we can have these generic rules, reuse them for more business specific rules. We can build them, we can share these rules and so on. Right? Apart from this, we have complex SQL rules. Let me pull in a couple of those rules quickly. And I say validate join. That's another rule. I save these rules and execute them. That could take some time depending on the size of the data. So now what is the significance of this is it's just DQ, but there are two things here. When you are doing this on large volumes of data continuously, like whenever your data changes, right? It gives you the ability, it's not only doing the data quality rules that are generated, but also profiling the data and running machine learning models to learn on this continuously. So I have run this in the past to show you what happens when we have been doing this over a period of time and jump to the results directly at this point. So these are the rules at any point, one point of time, right? These are the rules we just ran and all the rules are successful. But if we want to see these rules for a period of time, right? And how the data is doing. So as you can see here, that during the execution at these places, there is something doesn't look. The data accuracy shows that it's not 100% in these two instances. And when you correlate that with the completeness, looks like there are some nulls. And same thing, volume of the data, there are some discrepancies here. Right? Now we want to drill down and see exactly what happened here. So I can zoom in the time range and to see that in these two instances, definitely something is not right. So we can go here, right? So we can see that here, there are some rule failures. For example, these are the simple rule which says that not nulls should be, it should be 100% of data, but there are some nulls here, 50.4% nulls for item name, which is loaded at this point of time. Email, and so on, right? For each and every of our tables, it is scanning and finding, running all these rules and keeping tab of them. So when we are monitoring this data over a period of time, it's easy to learn and minimize the false positives. False positives are the biggest problem when giving alerts about the data. And we have put a lot of emphasis to minimize the false positives, because when we learn over a period of time, we are able to learn continuously. So far, any questions?
I think it's pretty clear. Everybody's following. I have no questions on my end.
That is great. So, yeah. Let me pull in this slide. Right. So you can see my screen, right?
Yep.
Okay, cool. So now one of the things that we have put in a lot of effort is the performance of execution, because we are not executing just one or two tables. We want to execute or monitor most of your important tables continuously, right? Like a camera. So this is one example of, for example, 190 GB. In this particular instance, there were about 8 tables, and we ran about 130 rules, and it was each instance taking about 26 minutes. And the rules consisted of complex joins, foreign key, multi-column unique constraints, and so on. So how do we do this? Is we do combination of things. For example, we, instead of doing full scans, we do first by doing the sampling and avoid the full scans wherever it's necessary. And we aggregate all the data quality rules into single scan of table whenever it's possible. We avoid scans. And then we execute, when the rules are executed, we execute on the source system as much as possible. And only when the computation becomes very expensive on the source, we pull in the minimum amount of data out of the source system in order to do the to do the data quality. So there are two reasons for that. One being is we don't want to put too much of a computation cost on the source databases sometimes, or it is much more cheaper to pull the data out and do the computation. So we do this combination of these two things in order to really speed up the performance. So finally, now we have seen the importance, right? I mean, sorry, we have seen the various means we have troubleshooted, and then yet, if we still see something has discrepancies, then how do we want to validate our raw data with our target data? In our case, what we have been doing is from the transactional database. Sorry for that. Sorry. Yeah, in this particular case, what we have done is from our transactional source, we have been moving sales and customer table into our data warehouse. In the data warehouse, we have some complex ETL, which performs the ETL and puts the data into our L2 table, right? And we want to validate that the data that is in the L2 table is exactly the same as in the raw data. So,
Dhiraj, we have a question now. Can you make rules that are cross lines, or they are just applying to a record, to a single record?
can you repeat that, Gene?
Yeah, sure. When you have a data quality rule, okay, can it refer other records, or it's just on the current records?
No, we have a combination of two both. So let me go back to the previous rule, right? Right. So one thing is I can go and do this on the entire table, or I can put a filter here to query a subset of the data. Like, for example, I want only the data which has changed in the last 1 day, right? And then that is a parameter, and that when you schedule to run, it's running only for the last, that duration of the data that changed during the period of time. Yeah. Did I answer your question?
Yeah, I think it is also relating to, if you've got two records, and when you're validating one record, can it refer to another record as well?
Got it. Right. So for that, right, if I go back, the data quality itself, what are provided out of the box is at the record level. But you can write the SQL using window operations to what you mentioned. It is not provided out of the box, but with SQL we can do that.
Yeah, okay. Thank you. I think that answers the question. I think so, at least.
Right. Yeah. So one of the things that we are doing is provide Groovy scripts to write the rules, and we believe that that's a debate, and most of the people have answered that it's really easy to write Groovy scripts to program. I guess I'll put it for a separate discussion. I'll not go in there. So going back here, so what we are doing here is validating that our raw data that reaches our final data warehouse, they are exactly the same, right? So I'm going to pull in again. Just completed that. Okay, here. So what I have done here is I have this SQL, right? Oh, not sure which screen I'm sharing.
You're sharing you're sharing the display screen. So yep, now we see the demo.
Right. Sorry. Okay. Right. So what we are doing here is we pulled in we pull in one data source, which is the raw data. And on that, I'm applying the ETL, same ETL logic on the raw data. And on the other side, which is Snowflake, right? And I pulled in the two tables. And the reason for the two tables here I'm doing is one table is it should be 100% matched, whereas other is we have some discrepancies. And to show the discrepancies, I have put two tables. Now, when I executed this, I jumped to the results directly here in the interest of time. So the data is validated between the source, raw data, which is Oracle Postgres, against the Snowflake. And we see that in this particular case, it's 100% matched, whereas here we have some discrepancies. Let's drill down to see the discrepancies, right? And we see that we have 93.28% match. And if we go to details, so we see that there are some source records which didn't reach the target. These source records have not reached the target. Now we have to investigate why. And some of them which reached, there are some discrepancies in calculations. We were expecting 201, but in the Snowflake, we have 100. Right? And there are so many of those discrepancies, 7,997. So with combination of monitoring the data and ability to validate the data with ETL validation, you are able to do complete automation of data testing and validation. Now, if I go back to the presentation. Right. And these are again just some of the data sources we connect out of the box. There can be a lot more. And apart from these data sources, you can connect a streaming data source like Kafka to do the validation against your data. And same thing you can do, apply data quality for the streaming data on Kafka or API. So if you have the data coming in from API, you can apply the same data quality rules and monitor the data coming through API, right there, even before it lands. Or various file formats in S3 or blob or so on. And you can apply, you can continuously run before the data is ingested. So, yeah, any questions at this point? If you like to set up smart cameras for your data, please visit DataQ.io to get started. Yeah, we can have any questions at this point.
So thank you, Dhiraj. This is great. Can you show us a little bit the different operators you can have on the data when you are in your because you showed comparison, but I know you've got a lot more than that.
Absolutely, we'd love to. So the first thing that we do is we pull in the input component, right? And again, the input could be a table, or we can have a SQL or multiple SQL statements, each feeding to the other, or various file formats here, as you can see. For example, JSON, or you can pull these file formats from different S3 or so on, or API. Once you configure your input data, right, you can do additional filtering Well, let me give a quick example. So, I pull in the same tables. Right. So I can, in addition, of course, I can pull in the data and then apply the filters further. Let's say I pull in go back here, sales table, cust ID. Okay. Greater than 10, apply SQL. And then what feeds into that is I want to remove duplicates from this data. So this guy, what columns do you want to remove the duplicates?
Okay.
And further, you can write this data temporarily to somewhere or select columns.
That's great. Yeah.
Right. These are the various components out of the box. And one of the things that's we are coming in is we got a request, and that's what we are trying to implement is ability to join data from, for example, before you have a source coming in from Cosmos DB, Azure Cosmos DB with a SQL database, and then comparing that with the final data in data warehouse. So basically, essentially pulling data from two different sources and joining the data.
Awesome.
Right. One other thing is profiling the data, then seeing the profile of the data over a period of time continuously. But again, going back, the main use case is how do we keep on monitoring the data over a period of time, both source and the target and intermediate stages.
Yeah, that's a great value. Guys, any more questions? Any comments? Is that a tool you would be using? I'm just checking. You can hear me. You can hear me well because I got mic issues. Okay, lost audio. Hello?
I got one question there. What is the tech stack used to build DataQ?
Yeah, go ahead.
We are able to hear you. Okay. So a tech stack, we are the tech stack to build is primarily built in Scala and Spark, but we are doing combination of things. So the main thing is we try to avoid pulling in data from the source systems when doing data quality. We try to execute as much execution of data quality rules on the source system, or what we call as data at rest, and only pull in the data or subset of the data if required, where the computation cost is a huge difference in computing it outside versus on the source.
And it's all cloud-based.
Right, yes. So quickly explaining about the architecture of DataQ, right? Let me fill in this one. Right. So if you are seeing the a high-level slide, how DataQ is, DataQ runs on a single node server because it is very lightweight. It has very low resource requirement because the heavy computation is easily executed on the source systems, like whatever Postgres or Snowflake and so on, or on the Hadoop clusters. So the deployment of DataQ is like, it takes less than an hour. If it's on Amazon, it's cloud formation scripts or for any other thing. It takes less than an hour to get started in your environment. And if you have any of the Hadoop clusters, EMR, Databricks, it leverages them. And if you don't, the execution happens on the same server, or if you have Kubernetes, it can use Kubernetes for computation.
So it's scale, like it's limitless, almost limitless.
Right, exactly. It's linearly scalable. It's basically gives you the control, the user the control, how much time they want the job to be executed in. So when we are executing a job, the user has the ability to either run it locally or on the Kubernetes or Databricks or wherever they configure. Let me quickly show that. Right. So here I can, by default, it's running on the DataQ server, or I can choose Databricks. And here on demand basically is an EMR cluster. And we can, when I pick Databricks, it configures how many resources it wants automatically. We don't have to explicitly specify that based on the size of the data. But of course, user can always go and increase or tweak it.
Yeah. So Mike, you have a question. It's a little bit of a complex question, but so I let you ask him directly, or you want me to ask Dhiraj about your question? I hate to read small font on my screen. That's my lazy side.
So Mike.
Oh, Mike, you don't have a microphone. Okay, so I'm reading the question. So from Mike, my typical question about a presentation on cleaning data for machine learning is, why can't we use AI and ML to clean up the data? It's a bit of humor, but also a bit serious. I think it's definitely very serious, Mike. I would agree with you. It seems by this presentation that by this point that we should have some unsupervised algorithm to assist an initial cleanup and analysis for at a minimum isolating outliers. What's your thought on that, Dhiraj?
Absolutely. See, the biggest challenge, in my opinion, or what we have seen, is the number of false positives. Now, just imagine if when we are doing this, when we go to the client, if I have 30 alerts tomorrow after 1 week, then how can I convince the BAs to go check these alerts and close them? Over a period of time, the system gets better. Absolutely, it gets better. But that is the biggest challenge we have.
Yeah, I get it. I think the idea is also to have systems that can start learning by themselves and over time see the patterns where data could be problematic. But there's so much business rules, and I'm in a few projects where like that. I'm not sure I would trust. I would trust the system to do this analysis, and especially with systems that varied over time. So I'm just taking an example of one of the project I'm working on, and I'm sorry to take over Dhiraj a little bit, but the issue is the business rules. It's a program that has like 5 to 10 years old, okay? And the business rules have changed. Some of the fields that were not required at the beginning are required now. Some of the fields that were at some strict constraint, like unicity constraint, at the beginning, don't have them now anymore. And it's how a system evolves. It's not like it's bad design or anything. It's just a business evolved and the system evolved with the design. And that's very difficult, and it's going to be very difficult for an AI system to detect that. But you have some data analysis tools, right? Like you can show, as you saw with your pie chart, you can show, maybe you can show that again, Dhiraj. You can analyze the data and show what the data is looking like. So you've got a sense of what the data is there. But I think the expertise is still needed there, both the business expertise and the business and the technical expertise.
Right. So the ideal solution is the combination of a domain expert with machine learning. That will give us high data accuracy. If I go back to the results screen here. Right. So these rules here are one, auto-suggested rules, combination with the rules which are provided by the domain expert. So the auto-suggested rules are at the column level. We are working on multi-column level auto-suggested rules. Like a good example is a sales data. If a person is going to a restaurant every day, that's not normal. But if a person is going to hair salon to spend $1,000 every day, that's not normal, right? So the multi-column rules is something that we are working on. And these rules at this point are all at the single column level. They're all auto-generated by the system looking at the input data as a training data.
So you're already using ML and AI at this point.
Yes.
So that's a good start already. Yeah.
Right.
And Mike, you're asking a follow-up question. So, but don't we have migration tools for evolution of data entry? So, can you specify a little bit more, Mike, about what you mean by migration tool for data entry? I'm a little bit confused by your question. Is it missing fields? So missing fields is more. It's how can we visualize missing fields in DataQ, Dhiraj?
Yes. So if I go back here, right? So we have the rules at the column level out of the box.
Yeah.
Or I can go to metadata, and metadata we have some basic things like, for example, I expect the column table size to be so much. I expect the column names to not change, data types to not change, and so on. We apply these rules. So when a column is dropped or renamed, it gives an alerts.
Okay. Yeah. So and that works with any data source. You're showing your two tables, but it could be on files as well.
Absolutely. The input could be files, API, Kafka, or whatever, anything. The same rules apply for that.
And as soon as you run your and the way I understand it is that DataQ runs permanently, right? It's not like you shoot it like well, it can run permanently. It's not like a batch system which you're running at 2 a.m. or something.
Yeah, it is running periodically as the data changes.
Okay.
Depending on the data schedule, it runs. And the longer it runs, the better it knows about the data and gives better results.
Okay. That works. Okay. Any more questions? Mike, did I? Oh, okay. One problem for Mike, one problem is with non-numeric input fields where new options are added or so removed. That's a difficult update. So Mike, I'm assuming that you want to do some kind of lookup validation. Am I correct? If so, is there you can do it with DataQ, because you can look up, you can have a SQL statement going to check on another table, right? So if you've got the values that are depending on another table, like a lookup table, it works. So and whether it's numeric or text will not matter. It all depends on your SQL statement.
Right.
And you can have things like as well. So you can, it doesn't have to be a perfect match. It can be a flexible match. Yeah, and it depends on, as I just said, and I don't want to speak for Dhiraj, but the way I understand it, Mike, is that when bad input is happening on something, as you validate it against the reference table or lookup table, then you can make sure that the data is valid and be rejected if it doesn't match. And you can have some tolerance, because SQL will allow you to have some tolerance with matches and like statements. So, but definitely this is a good use case for DataQ. So, I had a question from Nabil a little bit before. I hope, Nabil, I answered your question right. It's I hope so. So do we have any other questions? So your website is dataq.io, and you can find a lot more information there. This video will be on YouTube, and if we want a more personalized demo, I guess people can contact you, Dhiraj, right?
Absolutely.
Yeah. How much time does it take to onboard?
Less than an hour.
Okay.
Yeah.
So you're doing custom demos for people. So basically, we could, and whether it's in the cloud or on-prem doesn't really matter. It can be in a hybrid setting.
Right. Absolutely.
Yeah.
Absolutely.
That makes the tool pretty flexible.
Right.
If I want to build some complex rules, can I have some Java plugin or Java extensions or Scala extensions?
Not out of the box, but if there's a need, we can definitely provide the provision.
Okay. And that will have to be service you provide, or is it something that my dev team can do?
Your dev team should be able to do that. So we just have to give you the ability to upload the jar files for complex validation.
Okay.
Yeah, either in Python or Java, whichever works better.
Okay. Well, that's great. I've seen the evolution of this tool over a few years now, and every time I'm impressed by the stability and maturity it gains over time. This is how you also can spot a good tool. So I'm going to call for a last round of questions, guys. Any questions? Even Mike, you can type your questions. You know it works. I'm not picking on you. I'm just a bit teasing. I'm in a teasing mood today. Okay. So Dhiraj, thank you very much. This was very useful. Yeah, people seem to be really happy about the presentation. So Dhiraj Peechara, DataQ.io. Your email is, you can use contact us at DataQ.io. Thank you so much. And if you want to present for a next TASM, please reach out. Oh, thanks, Will. And so bye, guys. Have a great rest of your day. Bye-bye.